Good morning, everyone. Please welcome Dr. J.Rosenbaum with Gender Tapestry, New Ways of Looking at Gender Classification.
Thank you so much. Hi everyone, my name is Dr. J. Rosenbaum and I've earned a PhD studying AI perceptions of gender at RMIT. I'm also a sessional lecturer at RMIT and teach design students about the creative possibilities of AI and how to view it through a critical lens. My work in AI centers around the navigation and evolution of our understanding of gender. While I talk today, I'm going to invite you all to upload portraits of yourself to this system and watch it grow and change as more people use it. Upload a few different images if you really want to test it out. So yeah, this is a live demo. What could go wrong? I'm fascinated about the nascent stages of AI and how our evolving understanding of gender is entangled in our unfolding understanding of AI. I'm also interested in the ethics of gender classification and gendered images made by AI. So that's gendertapestry.com. And yeah, perception is unique to the individual. No person sees the same thing in quite the same way as another. Even color, something we learn as children, is perceived slightly differently by everyone. Not just by people with a perception impairment, but evidence suggests that everyone perceives color differently. Color is not a linear creation. It's more accurately exists on a 3D color spectrum. Gender does not exist in a binary or as a linear spectrum, but in a 3D space that's highly subjective. I want to discuss the similarities between color perception and gender perception. We all largely agree that the sky is blue, right? But what shade of blue exactly? The shade of blue that I experience and the shade of blue that you experience while looking at the same sky may be entirely different, or grey as it is today. Color is subjective, and in the same way, so is gender. My experience of my non-binary gender is unique to me because it encompasses not only my socialized gender and my own relationship with my body, but also the memories and experiences that have gone towards making me the person that I am. Who I am is unique, and my experience of my gender is also unique. It's impossible to fully equate one gender experience with another because our socialization, our performativity, and our bodies are all tied up inextricably in our gender and our gender expression. Cisgender people who have not explored their gender will still have a different gender experience to other cisgender people because no one person experiences anything exactly the same way. Gender and color have a long history of being used in gendered marketing, especially towards children and parents. In gender reveal parties, baby clothes, even the way we interpret colors and the names of colors. Although these colors were not always used this way, today pink is synonymous with girls and blue with boys, an epidemic of color and gender divisiveness. We're told that these colors are blue or pink in the same way that we're told when growing up that we are a boy or a girl. Most people have little opportunity to challenge that idea. But once we learn that there are other options and shades of difference between the two, our experiences grow and we change. Our world widens. This project is about widening that world, about creating a type, bing, bing, bing. No? Yes.
And Dana Shea, please go to Holby. Dana Shea into Holby. Thank you.
Sorry, just thought I'd wait for that. This project is about widening that world, about creating a tie between gender and color so that instead of receiving a gender classification, people would receive their own unique color mix. We often say gender is a spectrum without considering that it's more than a linear construct, and so is color. Gender Tapestry is a work that explores gender as a 3D color space. The final result is an evolving mosaic using the color results of the users and a GAN trained on their faces. The mosaic gains in complexity as more people interact with the system, and they receive their own custom gender colors. I particularly enjoy working with multiple AI systems in a complex network of multimodal interaction. Throughout my research, I've explored gender classification and its fallibility and lack of inclusiveness. So I may have started Gender Tapestry with the aim of creating a better way to look at gender classification, but in the process, I think I've explored a bit of a better way to look at gender. I recently showed Gender Tapestry at Acme in Melbourne and was delighted to see people's reactions as they found their faces in the mosaic. It was also interesting to watch people agree to participate or not. The majority of people who agreed to participate were younger, with older men in particular running away at the mere mention of the word gender. Users interact with this work by uploading their image to the classifier. It calculates a color result and presents the user with their image in that color. The photo they submit then becomes part of the training of the GAN, and the color image that is generated becomes part of the mosaic palette to reimagine the latest sample in the GAN generation. Gender classification relates entirely to the science we teach computer vision agents. Most classifiers use an entirely binary system with all variables like hair, makeup, even glasses stripped away. These classifiers struggle to classify people outside of the binary, as well as passing and non-passing transgender people. So I quit classification by leaning into the expressive signals that people use to signify gender, so that instead of teaching a classifier to just look at bone structure and eye distance, I taught it to see hair color and style, makeup, all the variable signs that go into the ways we express ourselves and our genders. I wanted this to recognize gender as a performative construct, rather than something built into our biology. I further queered the classification by using a multi-label classifier that allows for more than one classification, creating a set of percentages. In this way, I could receive 6 sets of numbers to mix the colors with. The first stage in this project was to train the multi-label classifier in TensorFlow, or, to put it more simply, a non-binary classifier. Most image classifiers, particularly gender classifiers, operate on an either-or system. Either the subject is female or male. Like comparing apples and oranges, traditional classifiers choose between 2 things, and if presented with something outside of those 2 choices, they try to shoehorn it in to one or the other. A classifier trained on either Barbie or Ken, when presented with rollerblades, will try to assign them to be either a Barbie or a Ken. It has no knowledge beyond the concept of the 2 choices it's been trained with. A multi-label classifier, on the other hand, is trained with several labels, and with images sometimes having more than one label attached. This is the key when looking at gender, as sometimes people have more than one label they like to go by. Thus, instead of actually classifying gender, I decided it would be less problematic to instead train the classifier in pronouns. Trans academic Dr. Susan Stryker discusses gender identity as something that could best be described as how one feels about being referred to by a particular pronoun. The multi-label classifier allows me to train based on multiple pronoun options for the many non-binary people who use more than one set of pronouns. The output of a multi-label classifier is a set of predictions presented as a percentage. I worked with 6 pronoun labels in this classifier, as 6 created more interesting variations in color. I I developed the test classifier on generated faces. So it seems a bizarre prospect to assign gender to people that don't exist, but it's actually a really interesting philosophical premise. The idea that an external person assigning gender or a machine classifying gender to a person they don't know seems really presumptive. Assigning gender labels to a fabricated person feels less problematic somehow. The pronouns I assign them are as artificial as they are, as much of a construct as gender itself. There is an artificiality to the entire project, and I think that's an intriguing premise, to classify real humans using a system that's been trained on artificial humanity. I chose pronouns instead of genders because it fit neatly with the nature of the multi-label classifier, because people often use more than one set of pronouns. I feel like there was something attractively artificial in the use of generated people to explore a social construct of gender and a machine assignation of something that's essentially fabricated. Color for gender is a concept that already exists, so why not subvert that and challenge the assumptions people have about each other and about themselves? Why not turn it into an experience? As gender is an experience, why not make something that shows how beautiful and varied gender diversity really is? I also found myself questioning the nature of bias as I developed this classifier. When the data set was evenly distributed, the results became murky, too hard to distinguish. I needed more categories and uneven distribution across the categories, something closer to population representation, in order to get the diversity of colors I wanted. I actually needed to build in bias to receive varied results. This was antithetical to all of my research and beliefs. I eventually had to use a public gender data set in addition to my fabricated one to skew the data set away from my idealized and balanced data. But because I am also very much biased, and it's a good practice for when you don't know people, they, them has the highest distribution. And as you can see in the right-hand column, moving from 3 to 6, categories biases the data a little more, just a little, made an enormous difference, even if I didn't like doing it. This helped make the colors more vibrant and variable. In the end, the results I receive are consistent across images. One picture will always receive the same color. But when testing on myself, I found that I received a range of colors based on my presentation at the time, all usually in the same color family, but subtly different. After training the classifier, I turned my attention to programming the key elements, the prediction tool, color generation, and image generation. This prediction uses the trained classifier model and some custom code to process the results from a standard NumPy array and turn them to individual integers that can be rendered in an RGB format. So I'm going to break down my programming that runs behind the scenes and explain not only how it works, but why, but also my decisions along the way. So remember, I am actually an artist and I don't necessarily have the best code. This was before ChatGPT. In this section, the trained model is loaded. The classes, pronouns in this case, are assigned to an array, and variables are created for the probability of each result and the rank of each result. Dynamic variables are generally bad practice, but in this case, it was necessary, as the number was output in a single NumPy array, and I needed to split that array up in order to work with the numbers individually. This section evaluates the image through each of the 6 results and assigns a prediction for each pronoun category based on the trained model. It initially outputs a series of numbers that are all under 1. So each number is multiplied by 100 so that we deal with whole numbers ready for mapping. The top 6 variable contains the format for defining the order in which the array is sorted. And the for loop ensures that the prediction runs through each format and assigns a dynamic variable to each. This section separates out the prober variable into 6 variables and cleans them ready for processing. It uses the find function to isolate each set of numbers and assign them a dynamic variable, and then to a variable redundantly called hex code. Originally, I designed this project to work with hex codes, and if I were to stick with those, all I would need to do is add them together at this point. However, the hex code colors were invariably boring, not vibrant like I wanted, so I formatted it to work with an RGB code instead. My concern with using RGB colors was that many results ended up being over 255, the maximum number of an RGB color. So I set it loose and I was expecting it to fail, but received instead a plethora of colors, exactly what I wanted. I examined the colors in a spreadsheet, trying to see if the higher numbers were chopped off at 255 or normalized in the middle at 128, but neither was correct. Inside the color processing code, any number over 255 was divided by 255, and the difference taken as the output. So I tested this theory by explicitly programming the modulo operator in, as you can see, and it made absolutely no changes to the output. So I found the problem, or the wonderful magic behind the thing. So I left it in, because it always looks better to have it explicitly programmed in, even if it was actually doing it behind the scenes. The final step in the completed code was to render the uploaded image, ironically, as a binary image. Using the assigned colors to create 2 new versions of the uploaded photograph, a light and a dark version, in case the color was too light or too dark to register properly. This makes use of the scikit image library's grayscale and thresholding abilities to generate a purely black and white image, where I then specify the colors on the 0 or 1 pixels and save it with a unique file name. This turned it from an interesting experiment to something about the user. And from there, the rest of the artwork started to take shape, a way of visualizing this as a community-based interactive artwork. The mosaic and the GAN development are part of the interactiveness, and as people use the work more and train the GAN further and add more colors to the mosaic, the more complex it grows. This represents not only the spectrum of color, but also our understanding of gender as it moves from very simple to increasingly complex, beautiful in its variety and complexity. As this work was completed in 2021, we were in lockdown, and I was very aware that I may have to pivot my entire PhD exhibition online. So this work, originally designed to be a site-specific projection work, became a web-based piece. I started panicking because I didn't want to rewrite everything again in JavaScript and TensorFlow.js, which I could have done, but I just didn't want to reinvent the wheel. So I researched ways to get Python projects online and was reminded of Django and Flask. So I started learning everything I could about Flask in order to put this project online. And I had it working relatively well. But then I added an upload service that overcomplicated everything. Being online, I wanted it to be locked down to faces. Just faces. No other body parts. Thank you. So I got the basic site working, but I struggled with hosting and connecting it to with the separate GAN server. And with my deadline looming, I enlisted the aid of a friend to help me get it over the finish line, and now it's hosted on Fly.io and works perfectly, and that's the site that hopefully you're all testing out. Initially, humans are taught how to perceive gender. They learn what gender is from their parents, teachers, and peers. And as they grow and learn, they learn to perceive gender how they want to perceive it. They research, or they don't. They learn and listen, and their understanding of the concept of gender grows. Likewise, machines are taught how to perceive gender by humans. They're shown images and told that these images correspond to genders. An AI will not update its definitions on gender unless instructed to. It will not change its perspective or enhance its understanding unless it's specifically retrained. It can only do as its instructions permit. It then falls to the people training the AI and constructing the datasets to ensure that it's trained without bias. A computer itself has no inherent bias. It's only taught bias as it learns and incorporates bias data and algorithms. And the people working with the AI, therefore, need to understand the potential for bias and the inherent issues in facial classification tasks, including gender classification. People are naturally, consciously or unconsciously biased, and their inherent biases creep into their work, as seen with mine. We can help subvert bias in AI by being self-aware of our own biases and our own issues. We can subvert bias by creating bias in other ways, as I found out, to make things more equitable or more beautiful, more diverse, more interesting. Gender is an ever-evolving social construct informed by experience and upbringing. Likewise, AI is an ever-evolving machine construct with human-supplied inputs that could be equated to a form of experience and upbringing. Raising an equitable AI requires the voices of many and the intention to listen when issues are exposed. As we're currently in the nascent stages of understanding AI, now is the best time to explore how they interrelate. Untangling the convergence of machine learning and social change is a key requirement right now, especially as AI development is so rapid. By the time my exegesis was published, many of the technologies discussed were considered obsolete. However, the themes and concepts, the methods used in questioning these technologies, and the exploration of gender must continue to be discussed. During the term of my PhD, some of the language around gender changed as we became more aware of each other and our identities. As AI and gender continue to evolve, they must be considered together and informed by each other's understanding and development. My work is about about exploring the nature of gender and the nature of perceiving gender. I've explored how to debias gendered works, how AI creates and genders images, and how to create a new way of perceiving gender as a color spectrum. We're at a critical juncture of technological and sociological advancement, both with the surge in AI training and with recent sociological advancements in how we think and talk about gender. The time is ripe to merge those developments and to realize that we can't train machines in the outdated social mores of the past, but rather to think ahead to a new stage of development and understanding of ourselves and our AI. Thank you.
Thank you so much, Dr. J. Do we have any quick questions?
If someone was to come up to you and ask you, what does my color mean? How would you answer that question?
Oh, I like that question. So the fun part about it is because of that modulo operator confusing everything, the colors don't map exactly. So we don't have like, red for she, her, and green for they, them, and blue for he, him, and so on. We've got, it's not as cut and dried as that. So the color means what you want it to mean, I think. It means that if it's not what you expected, and it probably isn't what one expects, that maybe it's something to explore. What does that color mean to you?
Awesome, thank you.
Any other questions from anyone?
Thank you for the presentation. I really loved how you combine colors and biases. I was just wondering how this project could also be used to extrapolate onto other kinds of biases, or kind of looking into how AI could work with other kinds of biases, just as with gender bias.
I could probably use it in different ways. I actually used the same data set to create a different artwork at the Science Gallery in Melbourne just recently, where it assigned different personality trait labels to people based, and it was largely a gender classifier, but it was, it was exploring the gendered assumptions we have around personality traits: assertive, dominant, nurturing, those kinds of words. And then from there, it was put into a stable diffusion output and then used in augmented reality. But people could then select their own terms so that it worked on their terms, not on the AI's, which I thought was a very important addition. So I think that you could apply the same classification kind of concept to a range of different ideas. This is foremost, it's an art project. It's very much an art installation, but yeah, there's more things that you can do to, add different biases and explore different options, especially with the different weights and biases and the weighting of the data, which I'm still examining.
Thank you so much, everyone, for coming, and thank you, Dr. J.Rosenbaum. We have your gifts. Thank you so much. So, we'll be back in 10 minutes with open source communities and 10 years of MicroPython with Damien George. Thank you.
Thank you all.